Hey guys, so today I'm going to talk to you about VideoLAN, the nonprofit, VLC, the project, and LibVLCSharp, the .NET library. All right. Just a few words about me. So I'm 29. I live in Asia currently, but I did spend a year in Amsterdam about 7 years ago, working in a startup doing Xamarin iOS and Android development and a bit of Windows Phone. And I've been working with VideoLAN and VideoLabs since 2017. I will explain to you guys the difference between those two entities. So the first part of the talk is going to be about the VideoLAN organization. I'm going to tell you everything about the nonprofit, what it does, who's in it, what activities, events, software that they are doing, everything. Second part is mostly going to be more technical about the VLC project itself, the architecture, the different components, how they work together, on which platform they work. And so the last part is going to be .NET focused, how to use it from .NET, on which platforms, all the features, and I will show you some code as well, a few videos of features. All right, so here we are. Some context. So I'm going to explain to you how this project came to be. And that was almost 30 years ago in France, when some students from École Centrale Paris is an engineering focused college, and some students wanted to play video games because they want to play video games. And it was a very early beginning of the internet, so multiplayer video games were really new. One of the first ones that probably most of you are familiar with is Doom. And so the students wanted to play Doom, right? The thing is, that university at the time had this kind of network, token ring architecture. And the problem with this network is that every network packet has to go through all the nodes every time. So the more nodes, the more people, the more users, the larger the latency. So it becomes impossible to play because you have too much latency. So the students came to see the administration of the school, and they were like, we need better network equipment to be able to do our homework. But the administration knew that they were joking. I mean, that was not the purpose. So they said, we cannot help you because this university campus, the whole equipment, the building, everything is managed by the students, including the network. So we really cannot help you. You're going to have to figure it out yourself. But you might have some luck talking to Bouygues. So Bouygues is a huge conglomerate that builds like half of the buildings in France. And so the students went to talk with them. They said, we can't help you, but maybe you should talk with TF1. TF1 is the oldest radio station ever, and they also do TV and broadcasting and all kinds of things. And they said, okay, we believe that satellite TV is the future, so if you do a project with us, we will pay for your network gear. And the student did. And that was the beginning of VLC. There was a 30-second stream before the whole computer crashed because there was no more memory, because it was very limited with memory and RAM and CPU. But it eventually worked out, and several generations of students worked on this project during the 90s. In 2001, the project got open sourced with the GPL license. Weeks after, macOS version came to be, thanks to a German developer, notably. And cross-platform at the time, during the 2001 release, meant Linux and BOS. So from the very beginning, VLC was architected to play network streams, right? Satellite TV and networks are unreliable by nature. So that's one of the reasons why VLC is really good at playing damaged or cut, unfinished files, basically. The name VLC means VideoLAN client, because at the time there was a VideoLAN server. At one point during the development, both components came together and the name VLC remained. But you can still stream with your VLC. So it does have server capabilities. You can stream video using it. Another project that was, so they worked on VLC, but there was a lot of components around multimedia. One of them was X264, which is a famous encoder that YouTube, Netflix, and others use to encode H.264 videos. I added some pictures from, I don't know, 20 years ago or something.
That's where the hat is coming from, Oregon.
Yes.
Cool.
So I think someone here already asked me that question. Does anyone have any idea about why this is the logo of the project?
I've always wondered. You would use it about something that's under construction, so...
Yeah, but that wasn't, I mean, yes, definitely it fits, but that's not the main reason.
A student stole a cone and put it on his hat? And
Yes, exactly, that happened. Good guess. So yeah, during Saturday night, I guess, they had a few drinks, and one of them just stole a cone and bring it back to the university dorms, and that became a habit to the point that they just had hundreds of traffic cones, and they started creating sports with it and playing with it. And when it came the time to choose a logo, that was the obvious choice. So yeah, during Christmas time, just a few days before Christmas, the logo changes and you have this on your desktop OS. And yeah, there are a few Easter eggs like this in the application. So in 2009, project grew and it needed its own structure. It needed to have more contributors. So someone named Jean-Baptiste Kampf, who is one of the oldest contributor to VLC, and he's still working with it, founded a non-profit organization based in Paris to manage the whole project and other projects around it. X264 is one of them. LibVLC, to be able to navigate Blu-ray menus in your own application. That's a DVD decryption library. This one is pretty new and almost entirely written in assembly code. There are more assembly lines of code in this than in FFmpeg, which is also one of the projects in the community. So sometimes people ask me what is the difference between VLC and FFmpeg. So FFmpeg is really a toolkit. If you want to cut or modify or do anything to your video or audio, you should use FFmpeg. If you really want a player API, you should use VLC, which ships with FFmpeg. And a lot of developers contribute to both. The FFmpeg Git repository is hosted on VideoLAN server, so those communities are really close, and they collaborate a lot. Matroska, the MKV, the Russian dolls, the MKV format is also very close to the whole VLC multimedia community. I'm working with the main maintainer, who's a large contributor to the Windows version of VLC. And everyone, so this is a software decoder project for this. And this is a new format developed in collaboration with YouTube, Netflix, Microsoft, VideoLAN, and many others who created a new codec, which is royalty-free because patents is a minefield in this ecosystem. And so libDavid is mostly developed by VideoLAN, and it ships in Google Chrome, in Windows, and other large projects. So, some numbers. 500 million active desktop and mobile users for the official VLC applications. So there is iOS, tvOS, macOS, Windows, and Linux distributions. There is no telemetry whatsoever, like zero tracking. We don't know where people click. We don't know which video they are looking at, watching. We don't know how many active users we have at any time. That's a strict choice that the VideoLAN people made because they believe that telemetry is spying and they want to have none of it. We do have some ideas of the downloads because we provide it on our website, but the Linux repository is also provided and you can download it on many other websites, so we don't track those downloads, but we have this counter at least. Contributors, you can check the Git repository for that, but there are quite a few, a lot of new ones every year who just send a patch or two and move on with their life, which is normal, that's the way it is. Code base is mostly 100,000 lines of C code, a bit of hand-rolled assembly, and a bit of C++ as well. If you add all of the plugins, because there is a core, but there is all kind of libraries around it, then it's more like 12 million of C. More pictures. So I believe IBC is in Amsterdam. IBC is, or is it NAB? Maybe, you know NAB? Broadcasting, Amsterdam Broadcasting, the N I forgot. Anyway, VideoLAN is present at many events, at least pre-COVID. FOSDEM, which is the main open source conference in Brussels. CES, FOSS Asia, which is the main open source conference in Asia, and the VideoLAN Developer Days. So those are VideoLAN organized events. They happen once a year usually. We meet somewhere. Last time was in Tokyo. It was really fun. A lot of technical talks and decisions on hard architecture discussions that require a meeting. That's always nice. That was at Las Vegas in 2019 when there was a live counter for our counter. So it doesn't count all of the downloads outside of our website, but there is a live counter on the VideoLAN website. So another question, does anyone have any clue?
Sponsoring?
What kind?
Maybe through GitHub or...
We don't use GitHub much.
What do you use then?
GitLab, we self-host our own GitLab instances. I will come to that as well.
Cool.
Maybe consultants
Consultant services?
for consultants who use open source.
Right. Yes, we do offer some consultant services. So donations is often an answer I get. It's not really sustainable to pay 20 people. I mean, the core team is maybe 20 people, then there are hundreds of contributors, but I don't know, we get maybe 30,000, 40,000 euros per year. It's not enough to pay 20 people full time. So this is not an option. I use this slide just to talk about a few different models of open source sustainability because I'm really interested in this subject. Another company I work with is called G-Research, and they use a lot of .NET, and they actually have an open source team inside to be able to fix issues in NuGet, MS Build, or the .NET runtime. And so one way to contribute or to sustain open source is to have your own internal team when you're large enough and you need to. Another one is when you already have an existing project, so that's VideoLabs, the VLC project, building consulting services around it. So that's the approach where you already have the open source project and you want to make it sustainable to develop it and to maintain it. So there is about 20 people in this company, and we do a lot of customization for VLC, for ASPs, for broadcasters, producers, various kind of companies. Those are the big ones, but there are a lot of smaller clients as well. So the Twitter account of VideoLAN is pretty active. If you're on Twitter, you asked me if we were on GitHub. We are not. There is a mirror, so you can still find our repositories, but we don't do any development on GitHub, and that's a choice from VideoLAN. That is the same for basically everything. We only use open source, and we only self-host on our own infrastructure, and that's the main choice for VideoLAN to be able to stay independent, and yeah, which is pretty unique, I think, in these days. So I wanted to recap a little bit, so I'm gonna go into the VLC project now, more technical. Plays all formats. I guess that's why VLC is popular also. You can throw any format at it, and you don't have to install codec packs for it to work. Network browsing, if you have a NAS system in your place, you can play video from it. HDMI pass-through, Chromecast support, I will get back to that. 360 video and 3D audio playback, where you can change the viewpoint if you recorded that video with a 360 camera. Audio channels, change the subtitles, size, and hardware decoding. DVD. About the Chromecast. So, that came in VLC 3. The Google Chromecast SDK is closed source, right? And VLC is licensed under GPL, which means that VLC cannot use the official Chromecast SDK, but people want to cast to their Chromecast. So another problem, and then I will explain the solution that VLC chose, format support. So people played, notably these, those are examples I found that the Chromecast doesn't support. So people are gonna play it in VLC, it's gonna work, and then they're gonna do cast, and then Chromecast is gonna be like, I don't know how to read that. So they're gonna be confused, right? So considering these two main points, VLC developers built their own open source SDK. So this was not an issue anymore. To be able to find a solution for this, they managed to do transcoding live when the format is not supported by the Chromecast, which means that VLC will check what Chromecast you have, because depending on the Chromecast, there is different format support. And if it's not supported, then before sending the content to the Chromecast, it's gonna transcode it to WebM or H.264. This was, so I have a few pictures from our talented designer, and I have a few goodies for you as well for the end of the talk. So that was for the 3.0 release, probably in Brussels, if I remember correctly. VLC to the future. He's really good. Whoop. You got it?
No, I see.
I got some of these for you. So, I talked about VLC, and now I'm going to talk to you about LibVLC. So what is the difference? Not much, just the UI. Basically, VLC is just LibVLC and the official UI. If you remove the UI, then you have just the libraries, right? And so anyone can go to, if you're on Windows, program files, VideoLAN, VLC, and you're going to see what DLLs are there. And those are what make up LibVLC. So LibVLC is a C library that anybody can use on any platform from any language. That's a cool thing, is because it's C. Most languages interoperate with C, so it doesn't matter if you're using Python, Rust, Java, Dart, Go, C#. You can use LibVLC. We also have a Discord server with all the people using LibVLC from all the languages. So it's really interesting to see what people are building with Go, with Python, with Rust, or whatever. But they all have the same features. Doesn't matter which language you're using, you're calling the same C functions in the end. So it's interesting. So how do you call C from C#? For those who don't know, you have mainly two ways to do so. C++ WinRT, which was C++ CX before that, which was what the VLC UWP app used, is Windows only. And platform invocation services is cross-platform and supported notably by Mono, so you can use it on mobile, on desktop, anywhere. So LibVLCSharp is using the second solution to be able to interpret from .NET to LibVLC. So portability, that's a cool thing, I think, with this, is that .NET is very portable, right? It runs everywhere, thanks to Mono, but also thanks to .NET Core and the whole new effort a few years ago. So .NET is very portable, runs everywhere. But the cool thing is VLC is the same. It runs everywhere as well. So when you use both, then you can pretty much target everything, which with shared code, even if you like, which is, I think, pretty cool. I think there was a Tizen app at some point, but that didn't last long. But VLC could, in theory, run on Tizen. And WatchOS, I think that got killed off as well a few years ago. But yeah, so you're not gonna have portability issues, is what I'm saying. So I'm gonna show you some code later. I just want to quickly give you an overview of the API, which is really simple. You have the main LibVLC object, which is used to create further objects, and you get a bunch of information from your system using that. Media player, play, pause, seek, rewind, the classic ones. You can also attach a media player to a video view, which is provided. The media could be anything. local file system, video file, HTTP stream, audio file, even from RAM. So you can also feed the VLC library from byte arrays if you want. Media Discover, that's what you use to find your NAS on your local network. And the Render Discover to find the Chromecast. Video View, this has nothing to do with C code. So all of these exist in C, right? And this is just binding over the C API. This is pure C#, and it's basically an integration with whatever GUI toolkit. So you can have a WPF video view, you can have a Windows Forms video view, Android one, iOS one, GTK one, whatever. Just a target to draw some video. This is the page where all the packages are. There are 16 of them. Those that are named VideoLAN.libVLC.something are the native ones. So they contain the LibVLC engine compiled for that specific platform. And then you have the LibVLCSharp dot something. So LibVLCSharp dot WPF, for example, contains the video view for WPF. And the LibVLCSharp one contains the main binding. So you always need at least two. You cannot just install LibVLCSharp and expect everything to run because you don't have the engine. You need the engine. And you cannot just install the engine because if you want to use it from .NET, you also need libVLCSharp. So the engine and then the .NET way to talk to the engine. There is 1.2 million something downloads, which is honestly not that much, I think, but it's also pretty niche in a way because, I mean, not every .NET developer needs to write multimedia application, right? And many of them probably can just use the WPF media element or the provided Android or iOS media player. So I guess this is not too bad. So this was a Xamarin Forms effort. So I was thinking, when Android developers want to play some video, they have a media player object or media player view control provided by Google or Apple. And me, what do I have? I have just the view, which is nice, but every developer has to code their own control, right? And you're gonna lose some time. So I was thinking with Xamarin Forms, if I only write this in Xamarin Forms, then people who use Xamarin Forms are gonna be able to just drag and drop this control and have everything working by default on iOS and Android. So this is to change the aspect ratio. This is Chromecast integration. The duration sigbar with the time remaining and the time elapsed, play pause, seeking. This is captions, so probably subtitles, and that must be the audio tracks. So yeah, it's an offering that matches more what's already provided by Google and Apple. Last year, VideoLAN takes part in the Google Summer of Code. Are you all familiar with Google Summer of Code? I'm going to explain that quickly. Basically, Google every summer organizes a way for students to contribute to open source, and so students apply to various open source organizations to spend their summer working on open source code, and Google will pay I don't know how much it is, like $1,000, $2,000 for the summer for the student, pays the student. So VideoLAN participates to, this is the logo of Google Summer of Code. VideoLAN participates on Google Summer of Code for like 12 years or 15 years. I don't remember when was the first time. And last year we had a student working on LibVLCSharp who contributed some features to this media player element. Yeah, so those are the features that this is provided as is for Xamarin Forms, but you can code it for any platform with any toolkit. There is no limitation here. I wanted to write a few words about licensing. Back on the open source sustainability topic I was mentioning. So this is a dual license project, LGPL 2.1. So I want to say a few words about this because I don't see many LGPL projects in .NET, and I am not a lawyer and licensing is hard. So I just want to say that there are no limitations when it comes to using LibVLC, which is also 2.1 LGPL, and LibVLCSharp in proprietary applications. You can use all of this code in your closed source apps without any problem. What the license says is that if during the development of your closed source or whatever application, you happen to modify LibVLCSharp or LibVLC, then you should be offering at least to contribute that back to the community if you modify the engine for your own needs. If you don't, if you just use it, then you don't really need to do much. But I am not a lawyer. I've started last year commercial licenses. This is now at 800 USD per year. This is where it's at, which is better than donations, but still not quite sustainable. But it's been an interesting experience to try to monetize an open source project, and it's always a challenge. So I'm gonna walk you through a few samples, which are on GitHub if you want to have a look. Where is my mouse? My mouse is here. Oh boy. And did not try that. Okay. Can I zoom here? Oh, I cannot zoom here.
Then you need Windows Plus. You have the Zoom tool.
Windows Plus?
Windows button plus, and then it brings up the Zoom tool, and you can just say, there we go.
No. All right. I am not familiar with this tool at all. Okay. So I just wanted to show you, so this is a GitHub repository which is full of samples, completely open source, to demonstrate many features from VLC. I'm just gonna show you the minimal one for starters, which is the simplest sample that you can find. So just to show you references, so you have LibVLCSharp, you have LibVLCSharp.wpf because this is a WPF project. Okay, and how do I zoom out?
Windows minus.
Yes, that would make sense, right? And here you have the LibVLC nugget, which I mentioned, which is the engine, right? So, I'm gonna show you the one page first. Sorry. So, very simple. One window, one grid, and the video view inside. Okay, so very simple. Just want to show you the basics and how simple it is just to get started. So when the video view is loaded, this event is started, and This is an optional call now, but it basically locates and loads the native library. So we create the LibVLC object, then we create the media player, and then we attach it to the video view so that we know where to draw the video. And then we just call play with a new media, which here is a video. And that's it. I could try play if I was living on the edge. Am I living on the edge?
Would be cool if you can play the live stream. It'll be like Inception.
Okay.
I'm trying to understand. Didn't you mention GitLab?
Yes.
And now we are in GitHub.
Yes, so I use both for the samples, and I also use GitHub to get some pull requests, but this is a mirror, mostly. Most of the code is... We do have a VideoLAN organization on GitHub, but the development happens on GitLab. Issues are closed on the GitHub repository. All the issues and merge requests and the CI runs on GitLab.
So you pay a fee to GitLab?
Nope, we self-host on the community and open source edition on our own infrastructure. So no fee.
What is the model, the earnings model of GitLab?
They have people who pay for hosting on their own infrastructure, I guess.
You might need to go into... Oh, that works as well. You can go to screen settings and move like the 100% to higher one, then everything is bigger.
Okay. So I guess it works. That's Big Buck Bunny, which is the main video used in samples. So there you go, just a very simple window. Let me show you gestures. Right. So this is a Xamarin Forms project, so iOS and Android. And I wanted to show you oh boy. Okay. So there is a gesture sample, which is basically a Xamarin Forms sample, which I'm going to show to you, where you can get the touch events, right, with Xamarin Forms when you're swiping down, swiping up, swiping right, swiping left. And this is used in the actual VLC applications to change the volume, for example, or to seek. And I think it is a very user-friendly way to expose this kind of features. And so I wrote a small Xamarin Forms sample to demonstrate that. So I'm going to show that to you if I can manage to zoom. Player control. No, probably. So this is a very simple page. So this is a content page which is gonna work on iOS and Android, right? And you have a gesture recognizer here, which tracks when you're touching the screen. And then there is an absolute layout with a VLC video view and data binding with the media player. And then the label just shows if you're the direction of your swipe, if you're top swipe, bottom swipe, left stripe. So the code where you control the volume and the seeking. And this is the wrong file. That would be the view model, probably. There we go. Right, so same thing, creating the LibVLC object, the media player, and then on gesture, so this is the function that is called when you're interacting with the touch screen. Running, so here we can just check the time. You cannot see the comment, but get the movie time in milliseconds. When the finger is going over the screen, you can calculate, because the event gives you the coordinates from the touch. So from that, you can make some calculation and change the current time by adding a bit of diff to either seek or rewind. Same for the volume. You can just ask the current volume from the media player, and then depending on the movement of the user, calculate a new volume. And at the end of the gesture, you just set it here, set the time or set the volume, which is pretty straightforward. This sample also has a 360 video which I'm going to show you directly in VLC because it's going to be easier. There we go. All right, so this is the VLC application, and this is a 360 video. And what they did is they just put that video on Eagle, because why not, right? And so I'm using the mouse right now, but I can also use the keyboard or the touch. If I was using this on Android or iOS, you can use the touch to just change the coordinate, or the zooming as well. So yeah, that's pretty nice. Okay, another sample, the last sample I wanted to show you is the Chromecast one, which is also very, very easy to implement. So YouTube, speech, there you can record as well. Chromecast, that's also a Xamarin Forms. So just to show you, if you go in references, so this is the Android project. It has the LibVLCSharp reference, right? And it has the Android version of the LibVLC engine, same in the iOS project. This is a platform-specific project. This is the share project, which just has the LibVLCSharp reference here. So, how to connect and stream to a Chromecast in .NET on any platform. So first, you're gonna discover the Chromecast, right? You're gonna want to find it. You can find many if you have several. So again, this is optional, but I put it here. You're gonna create a renderer discover object, subscribe to item added, which is an event, a native event, which is raised when a Chromecast is found. Then you start the discovery. When it's found, you will get information here from the event. And you will also know if that device can render video or not, because some Chromecasts are audio only. So you just keep a track of the render item here, and then you create a media player, and you have a function called setRender, which accepts render items. So you just tell the media player to render on this render item, which happens to be your Chromecast. And then you just press play. That's it. It's going to play on your Chromecast. If you do media player pause, then the media player is going to send a command to your Chromecast to pause the stream. All the transcoding, if it's needed, also happens automatically, so you don't have to configure anything. I have another sample which actually use MonoTorrent, which is a torrenting library from .NET, to download a torrent, and as it's being downloaded, feed it to VLC, which sends it to the Chromecast. So you could potentially, yeah, you can torrent. Exactly. So yeah.
Where is the code of codecs? Maybe a silly question.
You mean codec support?
I try to understand the codecs differences.
Right. So a lot of those are taken care of by the FFmpeg project, which is used by VLC. But your question is...
so it's another module.
There are many modules. Yeah, you have a MKV module, you have MP4 module, you have.
This is the module of the...
You mean the Chromecast? There is a Chromecast module.
Chromecast.
Yeah.
Okay.
But you can see in your installation, the VLC installation directory, they have hundreds of DLLs, all for very specific things. So
what are the what make the differences between the codecs?
The formats of how they're done, yeah.
The protocols.
Right, so you have the video format and you have the container. So container is the final format, the .mkv, .avi, .mp4. But then you have also the format itself of the video.
Okay, could be different.
And you have many, yeah, some are not compatible. Depending on what you want to do, some are better. And the support for hardware decoders.
Every codecs can have another module, for instance.
Yes, sure. So I need to come back to my slide. That's not gonna be, okay, sorry. Videos, Chromecast. So, what's next? So for the past a year and a half, I mean, basically since COVID, I started writing a book about libVLC, because I think that many people know about VLC, but not many people know about libVLC, and I think that's too bad because it's pretty nice. So I finished the book. It will be released next month. Now it's being designed because I'm not good at making it look pretty. So yeah, it will be an ebook about everything I know about VLC, VideoLAN, and specifically LibVLCSharp, all the main APIs, how to use it, best practices, troubleshooting tips, everything I know, basically. LibVLC 4. So LibVLC 3 was released with VLC 3 in 2018. Now LibVLC 4 is getting pretty stable and it's still being worked on, and it's already being used by various clients and users. If I needed to tell you about one thing of the new version of LibVLC 4, which will come out when it's ready, that would be this API. So in LibVLC 3, you could get individual frames as byte arrays or span memories, whatever, from the video using the engine, but that would require, in LibVLC 3, that required copies and CPU cross boundaries between GPU and CPU, which killed the performance and resulted in very high memory usage and CPU usage. So when you had 4K video, it was just not good. They fixed that in LibVLC 4. With LibVLC 4, you have a new API where you can provide your Direct3D or OpenGL, which are graphics API. You can provide them to LibVLC, and it will give you GPU texture back. So this is very efficient. I've been working for the past year and a half on a Unity 3D integration. Now it's currently working on Windows and Android. I need to do iOS. It's using LibVLCSharp and a C++ plugin, which does interoperability. But I also have a C# sample, which interoperates with Direct3D and LibVLC to do like rendering. But it's pretty low level. You need to be familiar with these APIs. But if you need to do real-time image recognition, or if you need to change your texture in any way, apply filters, whatever, you have hands-on, full-on access on it. So it's pretty powerful. Last thing I want to mention is WebAssembly support, which is a huge project still being worked on actively. I've seen some really nice demos where you have VLC compiled to WebAssembly running in your browser. So you can finally be able to watch your DVDs in Chrome, which is all you've been waiting for, I'm sure. But seriously, when it's going to land finally, LibVLCSharp will also bring WebAssembly support. So you're going to be able to write .NET applications that target your browser and play video with LibVLC inside. Main repositories, so all of the code is there. There is some code on GitHub, only mirrors. All of the development happens here. CIs, merge requests, issues, everything. For all of the projects, basically. There is my blog if you want to read more details about various samples. When I built an interesting sample, usually I write a small blog entry to walk you through the code. The NuGet VideoLAN account, the Twitter one, and ebook mailing list if you want me to let you know when it comes out. That's it. Thank you for listening.
Where does the any questions? Where does the name NuGet come from?
NuGet.
NuGet.
NuGet. I wouldn't know.
Okay.
I don't know.
Yeah, I was wondering something. The way I understand it is that the VideoLAN is a invoke wrapper that basically directly calls the LibVLC library, right?
Yeah.
Are you aware of any challenges that were around the performance of that?
Not that I know of, because the performance challenges would mostly happen when you have a lot of a hot loop, basically, like a lot of calls between C and C# that would keep running like this, right? Or if you just call play and then everything happens on the native side, then you don't have any performance issue.
Yeah,
right?
And I was sort of thinking what could be one of those things, if I'm for example, I use my finger to seek a certain timestamp in a video.
Yeah.
That could be one of those things where you.
If you're seeking a lot.
Loopy info calls, I was just wondering if there were any challenges there.
No, I mean the two APIs that are performance sensitive that I would call is the video API where you can get the frames outside from the engine. Every frame is like 16 milliseconds if you want them to display on time, so that has to be fast. So what we did with Unity is use, for that API that interoperates with the C, I wrote that plugin in C++.
Yeah, okay.
But I also wrote a sample in C# and it's fast as well. It's fast as well. Honestly, I don't think you're gonna have any bottleneck there, especially since .NET 5 you have quite a few performance improvements with interoperability,
Right.
where you can really get really good performance. The other API is audio, so there is an API to get decoded video frames, but you also have an API to get decoded audio data, which I did a sample with N-Audio, which is a .NET audio library, which allows to interoperate with your audio output when you can bridge that with VLC. But honestly, I didn't have any. No, when you have performance issue, that would be maybe on the C side, and that can be fixed pretty easily. So the C# part is never a bottleneck from what I've experienced.